Okay, so we're talking about the sample problems from section 1.7, and the last part we need to address is the rational inequalities when you have fraction inequalities. So again, because we have an inequality, this whole section we have the less than and greater than symbols, and we were talking about how to address those. So there's a rule for each thing you do. So for the linears, we just had to flip the inequality if we divide it by a negative. For the quadratics, we would solve them as we do quadratics, but then test point between each region. And for the last part, the rational, the rule is we need to get it into one single fraction, then set the numerator equal to 0 and the denominator equal to 0, and then do as we did on the quadratics, check within the regions. Now, if it's not already set equal to 0, do we have an example like that? No, let's see, number 12. Yes, you will have an example like this. Number 12, notice it's not a single fraction. You have to bring the 1 across the line. So the first step in solving any rational inequality is it has to be set equal to 0, and then we have to get this consolidated into a single fraction. So before we do that, though, let's do the easier ones. Now, number 10 and 11, they're already single fractions. So if it's already a single fraction, you set the numerator equal to 0. That tells us what would make the equation solved, the solution to it. If you put this over 1 and you cross multiplied, you'd have this times 1 and then equal to 0 times that would be 0. So this would actually be the solution. If you were solving it like an equation, you get x equals 3. Then the denominator set equal to 0 is another critical point for this fraction inequality, because it's what would make the equation undefined. If we plug in x is -1, we're going to get an undefined piece of this equation. And we're always preparing for graphing in chapter 2, and in graphing, those would be two important places along the x-axis. The 3, where it solves the equation, so it cuts through the number line and solves the equation at 3, and then at -1 would be where the equation is like confused because it's undefined at -1. The equation doesn't know what to do. If you were solving like in a t-table to graph that, at -1 it'd be, what is this? This is not even math. It gives me an error on my calculator. So it's another like critical point along our x-axis or our number line. So we have both of those involved, and then we need to test each region, region 1, 2, and 3. And I always like to take a test point wherever 0 is. That's the easiest one for me to start with. It's the easiest number to work with. So back in the original problem, 0 minus 3 over 0 plus 1 would be -3. Is that less than or equal to 0? See if it works. And that's true. -3 is less than or equal to 0. So my test point works, so I shade that region. Now, to be thorough, you'll check something like 4 in your problem over here, and then maybe -2. But let's say that we check those, and those two parts did not work. Those intervals did not work. So all the solutions lie between -1 and 3. Now, the next big important point we need to make is whether to use brackets or parentheses. Now, the rest of the problems I made a big deal over, talking about how the line under the inequality meant use a bracket. But think about this. Using a bracket means we include that endpoint in the solution set. Now, this particular value, -1, if we include it in the solution set, it's the part that makes it undefined. So that's not going to work. It's not part of the solution. So even though there's a line under it, the value that makes the denominator 0, it's parenthesis. You cannot include that in your solution set. Now, we should include the value 3 that we got from the solution to the equation, but always a parenthesis around what would make the denominator equal 0. So that boundary line that goes with the denominator is always parenthesis. So our solution set is from -1 to 3, one with a bracket and one with a parenthesis solution. Okay, let's do that again. A very similar problem on 11. We set the numerator equal to 0 to find what the solution would be. And then we set the denominator equal to 0 to find out what the critical value that makes it undefined would be. We put those along our number line. -3 is where it's undefined. 1's what would have solved the equation. Both critical points making 3 intervals. we take a test point. You know, I like to test 0. Plug it back in the original, would be 0 minus 1 over 0 plus 3. Is that less than or equal to 0? So that's negative 1 over 3. And that's negative, really anything negative is going to be less than or equal to 0. So that is true. So again, it's the middle region. It's not always the middle region, so don't think that's the pattern, but it was here again. Now for the same reasons as above, what made the denominator equal 0, the negative 3 cannot be included, so we use a parenthesis. Parenthesis means we include everything right up next to it, but not including that boundary. And then because there's a line under it, we will use a bracket around the other point. So the solution is negative 3 to comma positive 1 with a bracket. Okay, one more of these. Like I mentioned earlier, if it's not already a single fraction, you do need to bring any terms across the line and get it all on one side and the 0. Just like with the quadratic, you've got to get it equal to 0, so less than 0 here. But then we have to make this a single fraction. We have to consolidate those fractions. So, you know, we don't do this a whole lot. We haven't done this together, but to get a single fraction, we need a like denominator here. You can't combine fractions unless you have a common denominator. So we're going to say this is the denominator in use, x minus 4, so it can stay as it is, but I want to convert this fraction to a denominator of x minus 4. So we can say we're converting the denominator by x minus 4, so also times the top by x minus 4. And also, can you see that x minus 4 over x minus 4 is just another way of saying 1. It's equivalent to 1, so it's okay to write it in that form, but that form allows us to have like denominators. So now that we have a like denominator, that allows us to combine the numerators. So we have an x plus 4 on the left side, and then we're subtracting, so that will distribute minus x and plus 4 on the second fraction. So again, don't forget to distribute your subtract signs. Changes that to negative x and positive 4. Then we can combine like terms. X and minus x will cancel. 4 and 4 becomes 8. So we have 8 over x minus 4 less than 0. So all of that is the necessary first step if it's not already a single fraction and 0. Once you get it in this form, then we proceed like we did on our last two problems. You set the numerator equal to 0 for what would have solved it. Well, there's actually no solution to that. 8 equals 0 does not have a variable, so we don't get any answer there. But there is a value that makes the denominator equal 0. So we do have a critical value at x equals 4 is the value where the graph is undefined. So we only have the one boundary that divides the number line just into a left and right two parts this time. So now we're going to take our test point. Let's find 0. 0's over here, right? And plug that into the original problem all the way back up here. 0 plus 4 over 0 minus 4, is that less than 1? So 4 divided by negative 4 is negative 1. Is negative 1 less than 0? Or sorry, is negative 1 less than 1? This one in its original form had a 1 here. Yeah, that's true. So this test point works, so I'm shading that section. And then test on this side, maybe test 5, 5 plus 4 over 5 minus 4. Is that less than 1? So 5 plus 4 is 9. 5 minus 4 is 1. Is 9 less than 1? No, that is not true. So these values should not work. They're not part of the solution. So we just have this one interval. Because there's no line under that, I don't even have to question about the bracket or parenthesis, but it would have been a parenthesis if you want to know, because 4 is the value that makes it undefined. So we had to parenthesis that regardless. So negative infinity to 4 is where all the solutions to that equation would lie. All right, I hope that helps.